Welcome to the CarveWright Tips and Tricks January 2011 issue. In this tutorial, I'll show you some techniques for performing pocket cuts with your CarveWright machine. I'll go over the layout, bit selection, and bit assignment for each pocket type. This is part 1 of a two-part series. In part 2, we'll expand a little more on some advanced techniques for creating pocket cuts. For this tutorial, I'll define a pocket cut as a recessed area that's cut into the surface of a workpiece but does not pass completely through the depth of the material. Here's an illustration of what I mean. On the left, we've got a pocket cut. Notice it does not go all the way through the material. If a pocket cut did pass all the way through the material, we would simply call it a cutout. This is shown on the right. The CarveWright Designer software does not have a specific tool labeled Pocket Cut, but it does have a feature called the Carve Region tool. By using the Carve Region tool, this is the simplest form of a pocket cut. You can apply a carve region to any closed shape you draw yourself, or you can even make a pattern itself into a carve region. So I'll begin by showing you a few examples of creating simple pocket cuts using the Carve Region tool. Okay, I've opened a new project in the Designer software and turned off the board texture for clarity. I'll just draw a few basic closed shapes using Designer's drawing tools. Now all I need to do is select each shape and click on the Carve Region icon. This turns each of the enclosed shapes into a carve region. The default depth of a carve region is 1/4 inch, or 0.25 inch. I can select each individual shape and change the depth by typing in a new value for each one of them and then pressing Enter on the computer keyboard. Something you need to be aware of is that a project will normally use the 1/16 inch tapered carving bit to carve out the regions. This means that the sidewalls will have a 7-degree tapered angle and won't be perfectly vertical. The view in Designer doesn't show the angle. It appears to have vertically straight sidewalls, but the actual carve won't due to the geometry of the bit. The deeper the carve region, the more noticeable this angle will be. So if you need pocket cuts with straight vertical sidewalls, I'm going to show you a few methods on how you can achieve that. But before we move on, let me show you a couple more uses for the Carve Region tool. I mentioned earlier that you could use a pattern to create a carve region. Simply place your pattern on your layout, and I'll remove the feather on this particular pattern, and while it's still selected, click on the Carve Region icon and set your desired depth as shown before for the enclosed shapes. This procedure could be useful for creating a recessed silhouette effect for a sign or a plaque, for example. Another application is to create a recessed carve region on your layout, then place a relief pattern within it so that the pattern carving will stand proud of the underlying surface. You can apply a feather inside or outside around the region depending on the effect you're after. Generally, the pattern depth and the carve region depth are set to the same values, but you can experiment with the settings as you like. I use this feature frequently for many of the projects I design. Alright, let's move on to how to make vertical walled pocket cuts. There are occasions when your pocket cuts might need vertical sidewalls. If, for example, you need a slot or a dado to fit parts together, like this bread box, obviously you'll want the pocket cut or the slot made in such a way so that the part will fit properly within the pocket. Creating linear slots, dados, and grooves is fairly straightforward. Let's open a new project in Designer with a layout size of 37 inches by 11 inches by 3/4 of an inch thick. I'll make a rectangle 10 inches by 36 inches, and I'll center it on the workpiece. This will represent the inside panel of a bookshelf. Open the Snap menu and set the grid for 0.75 or 3/4 of an inch, and check the Snap Objects to Grid and View Grid boxes. Turn off the board texture and turn off the perspective view for better clarity. Okay, let's draw a rectangle that represents our pocket or dado slot. We've got the grid set at 0.75, so when we drew this, it automatically snaps, giving us that 0.75 width. We know this board is going to be 10 inches wide after we cut it out for our side of our bookcase. I want this slot to overlap a little bit so that the cutter goes beyond the edges where the pocket will be. Give us a nice clean slot. So let's make this 10 1/4, and let's center this vertically so we've got an equal amount of overlap. And let's assign the 1/8 inch straight bit, which is a synonym for the cutting bit, and let's make it cut 1/8 of an inch deep. I can either type the decimal equivalent, which is 0.125, or I can simply type the fraction 1/8, OK, and it automatically converts it to the decimal for me. In case you didn't know it, these will automatically calculate your fractions into a decimal equivalent. Very handy feature, not necessary to have a decimal chart, fractional conversion chart by your computer. Let me zoom in so you can see what's going on. When you assign a bit to a vector or an outline or rectangle like we've done here, the bit's going to travel along the center, and it's going to have an overlap of the radius of the bit. Well, we don't want that in this case because we want the bit to cut within this 3/4 inch wide rectangle. So we need to set an inset, and that's going to be 1/16 of an inch. That's half the diameter of the bit, and we've moved that bit inside our rectangle now, so we know that this is not going to go outside of the rectangle. Next, I need to draw a series of connected lines within this rectangle for our slot. We'll go to the Connected Lines tool, and we'll draw the lines here, but let's change the spacing for the snap. That way it'll make it a little easier to draw the lines. So let's go to Layout, Snap, and let's change that to 1/16 of an inch spacing. So now we have our line spacing at 1/16 of an inch. Let's go ahead and draw our connected lines. And you see how easy this is? This is automatically snapping to that spacing. We're going to assign the 1/8 inch bit to this series of lines also. So the 1/16 of an inch spacing will give us that slight overlap that we need to sort of hog out this area here. Okay, press Escape on the keyboard to get out of that connected line tool. Now we want to make this the same length as our slot, so that was 10 1/4. So let's type 10.25. Automatically makes it 10 1/4 for us. Go to the bit assignment, assign the same bit, the 1/8 inch straight, assign the same depth, which was 1/8 of an inch, and we have our pocket cut. One thing we want to do is to just get rid of this view just a second so we can see what's going on. We'll select those lines that we drew. We want to center those vertically as well, so there's an equal amount of overlap on either side of the width of our bookshelf board. We can go back and let's change the snap setting to 1 inch just to make it a little bit easier for us to space. Turn on the grid lines, zoom in, and let's say that we want this to be about 6.5 inches from this edge. So we got 1, 2, 3, 4, 5, 6. And let's make a copy of this. There's no need to redraw any more slots. We've already done all the work, so we can copy that. Make a copy by selecting Control-C on your computer keyboard, or simply go to Edit, Copy. Then you can paste a copy by using Control-V, or go to the Edit menu, select Paste, and scoot this to the next position wherever you want your next shelf to be. Make another copy, paste, and move this to wherever that next shelf is going to be. Final step would be to make this a cutout. We'll assign it a cut path, make our cut path settings I like to use minimum 4 tabs, 2 tabs a foot, definitely a 3/16 inch high tab height. Maximum pass on 3/4 inch material, we'll use 0.3. You can use whatever you want. We also want to make sure that this cuts out on the outside of the line. You can see here that it's going to cut out on the inside of the line. So flip cut, and that flips it to the outside of the line, so we know that we're going to end up with a 10-inch width here, just like we want. Accept it. I can hide this cut path, turn off the grid, and there we have it. We've got our bookshelf side with our slots for our shelves. And you can use this technique for any other type of pocket cutting or grooves or whatever you want to use in your design layout. And it gives you those nice straight vertical sides, unlike the Carve Region tool, which will give you those tapered sides. Using a straight bit will give us those straight vertical sides we're after. Now it's even easier if you have one of the optional CarveWright bits, the 3/8 inch bit. If you simply draw a rectangle 0.75 inches wide and assign the 3/8 inch bit, make that depth 1/8 of an inch, zoom in on this, center it vertically, make it 10 and quarter, and set the inset for the radius of the 3/8 inch bit, which would be 3/16, and that pushes that inside. Now notice in the preview, so you don't have to draw all the lines is the point I'm trying to make. So you get in the preview, you do see this little bit of a piece left over. That may or may not happen during the machining. That may just fly out of there, no problem. If there is any remnant left, it'd be easy enough to just swipe it with a narrow block with sandpaper wrapped around it. Either way, there wouldn't be much to remove by hand if you needed to. If you're really picky, you could always just draw, a single line down the middle and assign it the 3/8 inch bit if you want to. So if you do own the 3/8 inch straight bit and you're using it for creating 3/4 inch wide slots, then it wouldn't be necessary to draw all these additional lines in there. This is just showing you how to use the existing cutting bit that comes with the machine. This shows you a method of using the 3/8 inch bit and works pretty good for larger pockets. It saves a lot of machining time. The techniques I've shown you here can be adapted for use for any of those types of pocket cuts that you need to make for your projects. Let me show you how to create a pocket cut using the 3/8 inch straight bit. I've already opened up Designer. We've got an imaginary clock here. This is our imaginary front of the clock. And I've already got a cut path to cut out the circle of the clock. And let's say that we have a clock mechanism that's going to fit into a pocket on the back of the clock, and the pocket needs to be a 1/2 inch deep and 2 1/4 inches square. So let's click the R tool to flip to the rear of the board. This is our rear view. Click on the square tool and we'll draw a square and make that 2 1/4 inches square. Now I want to use our snap to snap interval of 3/16, which is the radius of the 3/8 inch bit. Click on Snap to Grid and View Grid, and let me zoom in a little bit. Make sure that this square is snapped on any of these grid marks. Go to our Connected Lines tool, and we're going to draw in sort of a serpentine fashion within this square the vector along which we want to assign the 3/8 inch straight bit. You see this is snapping nicely on the grid. Press Escape to get out of the Connected Lines tool. So there we have our 2 1/4 inch square and we have our vector for our bit to follow. Now all of these are going to be assigned the 3/8 inch bit, so I'll just select them all, go to our bit selection, hit the 3/8 inch straight bit. We know that the total depth will be a 1/2 inch, and let's make the max pass half of that, 1/4 inch. OK. So here we have our pocket, but remember the bit is going to travel along the center line of this outlying vector. We don't want that. We want it to stay within our 2 1/4 inch square. So we need to set the inset at the radius of the 3/8 inch bit, which is 3/16. So now that's effectively moved the bit inside of this 2 1/4 inch square. So there we have our pocket. We just need to select it all and center everything in the center of our clock. Let's turn off the grid lines, and I'll flip back over using the F icon for the front view. There's the front of our clock. Now if this is a real clock with a mechanism inset in that pocket, we would have the shaft coming through here. Let's click on our drill tool, and we'll just click a hole anywhere. This is, let's say the shaft is a 1/4 inch in diameter. Now we could leave this at through the board. Now we know that the back is going to be carved away first, so there's really only a 1/4 inch of material left. So we could, if we wanted to, set the depth to just slightly over a 1/4 inch so that the bit would pass all the way through the material that's left, but I'll just leave it at through the board. Click OK, and select this, and we want to center this in the center of our workpiece. And so we've got our hole for the shaft of the clock mechanism, and on the back we have the pocket where the clock mechanism fits into. Now you notice because the bit is round, the radius of the bit is not going to give us a sharp corner. If it's absolutely necessary to have a sharp corner, you can come back after the carve and clean this up with a corner chisel or a hand chisel or whatever handy tool that you have. But chances are that this radius wouldn't be too much of a problem for this particular application. It's up to you. Alright, let me show you one more pocket cut method using this time the drill function in Designer. This could be for, say, a cup holder of some type. Maybe you're making a layout for a coffee cup holder. Let's say that we want the pocket to be 4.5 inches in diameter, big coffee cup. Set the depth at a 1/2 inch and the max pass at 1/4 inch. That means it'll take 2 go-arounds to reach this final depth of a 1/2 inch. And you just simply place this wherever you want to on your layout. But that's a quick and easy way to create round pocket cuts using the drill tool. This can also be used to create round boxes, and maybe you want the box in sections so that you can glue them together. It's very similar to a project I did for one of the tips and tricks a couple years ago, I think. And let me just show you how that was done. I just created the round pocket cut like you see here, and let me center that on the board. Go back to our front view, and this was a 4.5 inch diameter circle. Let's say we want to leave a 1/4 inch bit of material around this bottom portion of our round box. So we need to make another circle 5 inches in diameter and center that. And let's make that a cut path. Make our cut path settings. Max pass 0.3 for 3/4 inch material. Flip the cut so it cuts out on the outside of this circle. Accept. And there you have the ring with the interior pocket cut. If you want to put several of these on the board, we'll take the center off, move this around wherever we want to, make a copy of it, paste it, and place this on the board wherever you want to. Let's say that this is actually going to be a box section, so we don't really want this to be drilled, so I'll delete that, and we'll draw a 4.5 inch diameter circle. I'm going to center it. I'm going to center this copy of the cut path that we had. Okay, now we've got these aligned. Make this a cut path as well. Make our settings. In this case, we do not want a flip cut. We want that to remain cutting on the inside. Select them both, remove the centering, and scoot it around the board. So what we have is our bottom section of the box with our cavity, our pocket cut cavity, and this will simply be cut out as a ring for our box section that we glue on top after the carve. To sum up, we've taken a look at some basic techniques you can apply for creating pocket cuts for your projects. You've seen how to make simple pocket cuts using the Carve Region tool, how to make linear pocket cuts by drawing vectors and assigning bits to the vectors, how to make rectangle or square pocket cuts using a similar technique as linear pockets, and finally, a quick and easy way to create circular pocket cuts using the drill tool. This concludes part 1 of the pocket cutting tutorial.